Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, I will present about adsorption topic. Before starting my presentation, I would like to introduce myself. My name is Haikal Ramadhana Akmal with student ID 2009. So, our case study here about the MOF biochar composite for environmental protection and pollution control. So this is my reference for adsorption material, and here by the name of biochar composite for environmental protection and pollution control. So the study overview of the MOF biochar composite. There is 4 points here. The MOF biochar as advanced composite material can application in environmental protection and pollution control, combination of the metal organic framework and also the biochar, and high adsorption capacity and selectivity. The study focused on metal organic framework biochar, while the composite and advanced material for environmental remediation. This composite combined the porous structure of the MOF with the stability of biochar. The synergistic interaction between the MOF and biochar enhance the adsorption capacity, selectivity, and stability. This makes MOF or BC promising the solution for pollution control application. So we jump into the structure and properties of the MOF. There are 4 points here. The first one, the height, surface area, and porosity. The second one is functional group on biochar. The next is about the metal type in MOF, and the last one is the tunable structure and composition. The MOF BC composite possesses a highly porous structure with a large surface area, which enhances their adsorption capability. The presence of the functional group on biochar contribute to active adsorption site. The metal center in MOF provide the additional interaction site, enabling the selective adsorption. The structure can be tuned to target specific pollutant effectively. Next is the adsorption concept. There is 4 points here. The adsorption as a surface phenomenon, like the physical and chemical adsorption, role in surface area and porosity, and the key mechanism in MOFBC. The adsorption is a surface phenomenon where the pollutants are captured on the surface of a solid material. It is the main mechanism in MOFBC composite. Both physical and chemical adsorption occur simultaneously depending on the pollutant type and surface properties. This enhances the overall performance. Next is the adsorption advantage and feature. And there is 4 points here. The first one, the high efficiency and selectivity. Next is reusability and stability. Next is eco-friendly material, and the last one is future development potential. The MOFBC adsorption system over high efficiency, selectivity, and reusability. These properties make them suitable for environmental application. The future research such focus on the scalability and cost reduction, and this will enable the wider industrial implementation. Next is about the electrostatic interaction mechanism. There is 4 points here. The first one is attraction between the charged pollutant and surface. Next is about the role of the surface charge density. Next is the functional group influence the effectivity. And the last one is the effective for heavy metal and dyes. The electrostatic interaction occurs when the discharge surface of the MOFBC attract the oppositely charged pollutant. This mechanism depends on surface charge density and environmental condition. The biochar functional group enhances this interaction by providing the additional charge site. This mechanism is highly effective for removing heavy metal and dyes. Next, about P2P interaction mechanism, the interaction between aromatic rings, the p electron stacking, the MOF and biochar contribution and effective for organic pollutant. There is 4 points that I explained before. The P2P interaction occurs between the aromatic structure of the MOFBC and organic pollutant. These interactions are based on the electron P system. This mechanism is particularly effective for removing organic pollutants such as dye and PAHs. It enhances the absorption selectivity. Next, we jump the hydrophobic interaction. The four point here. The interaction with the nonpolar molecules, van der Waals force, surface hydrophobicity, and removal of the pharmaceuticals. The hydrophobic interaction occurs when the nonpolar pollutant interact with the hydrophobic region of the MOFBC. These interactions are driven by the van der Waals force. This mechanism is effective for removing hydrophobic contaminants such as pharmaceuticals and pesticide, pesticide surface modification and hence this capability. Next, we jump the ion exchange mechanism. There is 4 points here. The first one, the exchange between ion in solution, the role of functional groups, selectivity control, and effective for charged pollutant. The ion exchange involves the replacement of ion in the solution with the ion on the MOFBC surface. This mechanism depends on the presence of the charged functional group. It is highly effective for removing heavy metal and ionic pollutant. The effective the efficiency depends on the composition and the composite. Next, we jump into the pore filling mechanism. There's 4 points here. The first one is diffusion into the pore structure, role of the pore size distribution, amount, biochar, and synergy, and the last one is adsorption capacity enhancement. The pore filling occurs when the pollutant molecules diffuse into the porous structure of the MOFBC. This mechanism relies on the pore size and accessibility. The combination of the MOF and biochar enhance the adsorption through the synergic effect, proper for design and improve the efficiency. Next, we jump into the surface complexation. And there's 4 points here. The first one is formation of the chemical bonds, coordination with metal site, functional group involvement, and strong adsorption. The surface complexation involves the formation of the chemical bond between the pollutant and active site. This includes the coordination with the metal ion and MOF. The functional group on biochar contribute to strong interaction, and this mechanism improves the adsorption, stability, and selectivity. Next, we jump into combined absorption mechanism. There is still 4 points here. The multiple mechanism simultaneously, the physical and chemical absorption, the synergic effect, then and also high selectivity. The MOFBC composite utilize the multiple absorption mechanism simultaneously. This include the both physical and chemical interaction. The synergy between the mechanism enhance the absorption, efficiency, and selectivity. This makes the material highly versatile. Next, we jump the theoretical modeling, where the DFT is used to analyze the adsorption mechanism at the molecular level. It provides insight into the electronic structure and interaction. This method helps to predict adsorption site and binding energy. It supports the design of more efficient materials. Next, we jump to the key parameter affecting the adsorption. There is 4 points that the key of the parameter. The first one is pH, which is temperature, contact time, initial concentration, and coexisting ions. Several parameters influence the adsorption performance, including pH, temperature, and contact time. Like this factor affect the adsorption efficiency. Other factors such as initial concentration and competing ion also play a significant role in optimizing is necessary. Next, we jump into adsorption performance. The MOF composite demonstrates the high absorption capacity for various pollutants. This include heavy metal, dyes, and pharmaceuticals. The materials show the rapid absorption and highly efficiency. This makes them suitable for practical application. Next, for the environmental application, it can apply in water treatment, air purification, soil remediation, and carbon capture. MOFBC composites are used for removing contaminants from water and air. They are effective in treating wastewater and polluted environment. They are also used in soil remediation and carbon capture. Their versatility makes them highly valuable. Alright, I think that's all from for my a presentation about the adsorption material. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.